Okay, so today we're going to be classifying rational numbers. This is the start of your Unit 2. Before we do that, we're going to have a discussion real quick. So it says the following locations are being organized below. Use a diagram to discuss the questions. So if someone is from Houston, which is right here, then they are also from Texas? Yes. So you know for a fact Houston is is a city in Texas, so they had to be from Texas as well. But you see also Houston's inside the Texas box. So that's true. Is someone from Harris County also from Houston? They can be. So Houston is in Harris County, but Harris County has multiple cities. So like, let's say Quinlan is in Hunt County. Well, Greenville is also in Hunt County. So you can't say everyone in Hunt County is from Quinlan because some go to Quinlan, some go to Greenville, and so on. Next question is, if someone is from Austin, then which part of the diagram do they belong in? Well, Austin would have to just be in the Texas part because Austin is in a county called Travis and Hayes County. They're not in Harris County. So they don't belong in the bottom squares. So the number system classifies numbers based on their type and categories, like what we just did with this scenario. So there's 3 different types of numbers you're going to learn about, and you might have heard them before. Whole numbers. Whole numbers are the set of all positive counting numbers starting with 0. An example would be 0, 4, 7, 14, or just from 0 to positive infinity. The integers is a set of whole numbers and their opposites. So an example would be -5, -10, +10, 3, -18. So as I always say, they're whole numbers that can be positive and negative. Rational numbers are actually every single number you know. So a rational number is also an integer and a whole number, but they also include numbers that can be written as fractions, terminating decimals, and repeating decimals. Examples will be -5.6, 3/4, 3 1/6. So now what we're going to do is we're going to classify them on a Venn diagram. Or we're just going to look at the parts of a Venn diagram. So you see how rational is the biggest square? And inside the rational is integer and whole. Well, inside the rational is an integer, and inside that is a whole. So that means if you're a whole number, you're also an integer and a rational. If you're an integer, you're also rational. So the question is it possible for a number to be both a whole number and an integer? Why or why not? Yes, actually, that is very true. For example, the number 7 is a whole number, but also an integer and also a rational. So basically, if the number belongs in the bottom or the middle square, then yes, it is a whole, yes, it is an integer, and yes, it is rational. It's all 3 of them. So we're going to practice placing these numbers where they belong. So it says, use this graphic organizer below to correctly place the values. So -9 is rational, but is also an integer because it's not a fraction or decimal, so it belongs in the integer. But it's not a whole number because it has a negative. So next one is 0. 0 is rational, 0 is an integer, and 0 is also a whole number. 1/8 is rational, but it's not an integer because it's a fraction. And since it's not an integer, it cannot be a whole number. -1/2 is the same idea. So that's a fraction, so it cannot be an integer. And since it's not an integer, it cannot be a whole number. Next number is 15. 15 is rational, and it's also an integer, but it's also a whole number because it's positive and it doesn't have a decimal or a fraction. 126 is rational, is an integer and a whole number because it's positive and it doesn't have a fraction or a decimal. -37 is rational, and it's also an integer because it's not a fraction or a decimal, but it cannot be a whole number because it's negative. And then finally 2/3 Sorry, guys, my computer's slow. And finally, 2/3 should be rational. And then I'll just use... And then 2/3 is rational because it's a fraction. So it means it cannot be an integer or a whole number. And this is what your screen should look like. And I'm also missing 2/3. So this should be a 2/3 right there. Okay. A set of numbers have been classified below. Determine which numbers are incorrect. Okay, so negative 1.0. So negative 1.0 is right here. That's not correct because it's in whole numbers. A negative cannot be a whole number. Whoops. So no, negative 1 is an integer. Because negative 1.0 can also be just negative 1. 10 over 5 is correct because 10 over 5 is the same thing as 10 divided by 5, which is 2, which is a whole number. Negative 7 is correct because that's negative 7.0, which is the same thing as negative 7, and that is an integer. Negative 8.5 is incorrect because it's a decimal. It's a rational number. It cannot be an integer. Negative 9.7 is correct because it's a decimal. It belongs to be in the rational section. 3 over 6 is a fraction. It cannot be reduced. Well, it can be reduced to 1/2, but it's still a fraction, and it's irrational. And 3/4 is a fraction and belongs to rational. Negative 8 over 2 is incorrect because negative 8 divided by a positive 2 is negative 4. It should be an integer. And that's all we're doing for classifying rational numbers. Thank you, guys.